too. But remember that logs and exponential functions are inverses. So they should be symmetric, just like inverse functions are, and I'm going to show you what that means in a minute. So we're just going to graph the function 2 to the x, and we're going to graph the function log 2 of x, so you can kind of see their similarities and their differences, and why they're inverses of each other, and maybe how to pick what points to pick on here also. So I'm just going to graph them on the same one. If you'd rather make 2 graphs on your paper, since you don't have different colors, that's okay. Are you playing basketball, Grady? Your knee's good?
Not really, kind of.
You're just playing on a bum knee?
We learned about her knee yesterday.
Why do you?
Well, Katie came in and talked about the knee. He said how great there is. She showed us. Katie, the animator, and she showed us which one you used.
Mr. Love was very concerned after school yesterday when I saw him because Dylan told him about the 2 strikes, and he's like, someone told me today that you told them I had 2 strikes, and I really didn't mean anything by it. And I was like, Mr. Love, I was just teasing.
Did he call you Tiffany again?
No, but I told him that you said that, and he's like, when did I call you Tiffany? And I was like, I don't know, but it's not a big deal.
What do you guys normally call each other? Like, do you call him Zachary? Do you call him Zachary?
No, but I did learn this summer that he spells his name Zachary with an H, but if you call him Zach, it's just with a K. And I had it in my phone wrong.
But it's CH, like C-A-C.
It's Zachary with an H. But but when he writes Zach, he does it with a K because his parents are
But
crazy.
doesn't he not like Zach? He likes Zach. He likes Zachary better.
I don't know. But when we were
know that, but he does. He doesn't like Zach. No, people would call him Zach, and he got really mad.
well, you don't call your teachers by their first name.
I know, we didn't know that. Well, we call Cohen. Well, except for Cohen, because he's Cohen, and we don't like really Wilder that much, so.
Oh yeah, mistakes I told Zane about here. I was really upset. I texted him. I was like,
Dang it, Tiffany.
I texted back.
It was so funny. Grady was taking his test near after school yesterday, and a few people gave me their homework to regrade because they felt like that it was graded incorrectly. And so I just regraded it. Like, I just disregarded the grade that the person that graded it, and I just regraded it. And so I did Zane's, and he ended up getting 1 less point than what the person gave him, and I started laughing, and I said, oh, Zane just lost 1 extra point by having me regrade this. And Grady's like, maybe you shouldn't regrade mine.
Did you regrade mine?
Yeah, but everyone else got more points back, but Zane, I lost that.
Oh, so we give him max points.
You really took off the line.
You had to regrade it. It's just a point.
You go, dang it.
This is what we did in free 1. This is not that bad to graph. You just pick powers of 2. You just pick any number for x, but normally I pick 0, 1. I'm just going to write this and not talk because it's not working so well. You can pick anything though, but if you plug a negative in here, remember you get a fraction, so you get 1/2. 2 to the 0 is 1, and when you plug 1 in there, you get 2. You plug 2 in there, you get 4. You plug 3 in there, you get 8. And it's exponential because it's growing at a rapid pace. So when I graph that, remember that we have this y-intercept of 1 unless there's a transformation. And then this side is just going up like this, right? And this side has that horizontal asymptote because no matter what you plug in for x, you can never get 0, you can never get a negative number. Yes, we did that last week. Vague memories of that. I did that on the worksheet I just graded, which I do. I hope this time to end because I really want to talk about the backside of that worksheet because we had some terrible rounding issues because you guys didn't think about the problem. You just rounded like math rounding instead of science rounding.
You know what, like when you're in preschool, they make you say like I'll use my sister's example. She's a preschool teacher, Miss Whitney, and they'll use.
They do.
When did they change it?
I think it's because little kids have trouble saying things, and so sometimes people have weird last names. When my son went to kindergarten, because he's been in daycare and preschool, and so he always had Miss Shelley and Miss Cindy and Miss, like first names. And then his first day of kindergarten, he's like, Mom, my teachers have really crazy names because he didn't know because they were last names.
Your parents named you Dixon?
Like it's just a weird.
That's actually a name. Dixon's kind of a normal name. You should
Dixon,
have thought it's not weirder.
Yeah. Do you know someone named Dixon?
90210.
90210.
That's my daughter right now.
Okay, when you're doing this, you could try to change it, but the idea is think about what this represents now, right? Y is the exponent. This is your powers of 2, like whatever your base is. So when I do this, if I'm picking x values first, I pick powers of 2. So 1 power of 2 would be 2, right?
And then there's 4.
So log 2 of 2, what is the exponent that gives me 2?
1.
Oh, notice
It's opposite.
it's opposite. The definition of inverses are the x's and the y switch. So if you wanted to just pick powers here and put your the multiply out over here, but I usually just pick the base. I pick 1 over the base because what exponent would give me 1/2? -1. And I pick 1 because what is log anything of 1? 0. So again, idea is pick easy points. If you don't have a fancy calculator that does log base 2, you can't just put any number in here for x because we only know the powers of 2 right now. If it was 7, we would only be able to pick powers of 7 because we don't know the other ones. So when I graph this, you should know that all of these points have switched. So now when x is 2, y is 1. When x is 1, y is 0. And when x is 1/2. And we could keep thinking, we could pick powers of 2 all the way on the x value, right? Like you could pick 32, and that would be a power of 5. You could pick 64, that would be a power of 6. So this side's going to go up very slowly. Like what would the next one be? 2 would be 4, right? 3, 4, 2. At 8, it would go up to 3, but I'm just going to go like this and make it go up very slowly. And remember we talked about yesterday, you cannot take the log of 0, you cannot take the log of a negative number because there's no exponent that gives you that. So notice on the graph that this has a vertical asymptote because you will never get 0 in your x column, you will never get negative in your x column. So if you know what exponential functions look like, log functions are just the inverse of that, and inverse functions are reflective about that line here. So if you want to think about it that way, you can. Any big memories of this? I feel like we don't graph logs that often because we do have graphing calculators, but just in the basic idea I think is important.
So, would you ever have a problem where it has to graph both of those?
Probably not. No. This was just to start us off. But let's compare these two. I think that's my next slide. Oh no, there we go. Let's do ln, I guess, first. Maybe we should go back. Let's see if I have this slide. If not, we're just going to. Oh yeah, maybe I did. ln. If I gave you a graph to graph ln, you would have to use a calculator because you have to pick powers of e. Remember that ln is just log base e. So there are certain numbers we can pick that are going to give us nice answers here. Like, what if I picked 1 for x? What is the ln of 1? Or what is, not using your calculator, what is log anything of 1? 0. Good news is you can use your calculator on that one, but you should know. Another number I could pick, which maybe you need a decimal to help you know what e is, but if you picked e for this, what is the ln of e? It's just 1, because it's the same base.
Even if so, that's hard to calculate. First power, first power.
So I'm okay, I want to show you these points, but you can pick whatever you want for x except certain things, right? Like, could I pick 0 for x? Can I take the ln of 0? No. Could I pick a negative number for x? No, I can't take the ln of a negative number, and your calculator will help you with that. But you can pick whatever you want, like pick 4, and you just type it in your calculator. going to be an awful decimal, which is why I hate graphing ln.
So do you type in LN for these? Or?
Yes, you're graphing exactly what's there. And so ln right below log on my calculators, and I just get like 1.4.
I actually got 1.86.
It's under graph. I don't think I'm gonna be able to tell the difference between 1.38 and 1.4. Right? And I'm gonna plug a bigger number in just to see. Like I'm gonna plug 10 in there, and you don't have 10 on your graph. That's okay. But if you plug 10 in there, it's 2.3. So again, the idea behind logarithms is they increase very slowly. When I gave you those 10 graphs that you should know, we graphed ln of x, and we said that it goes up so slowly that if you measured it in like feet, that you'd have to go, I forget what it was.
Miles.
You had to go forever miles just to go up 1 foot because it increases so slowly. 1, 0. E is like 2.71. So that's like 2.71, 1, 2, 3, 4, 1.4, and 10 is 2.3, which is still going up very slowly. I'm looking that you have a smooth curve. I'm looking that you've made a couple points, and I'm looking for the general shape. Again, bad thing is if you don't show your asymptote. Like if you make this come all the way back here, that means you're going to get points taken off. Or if you just stop it there and you don't make it go down showing that it's an asymptote, you would get points taken off. It's the shape that I'm looking for, that you have an idea what the shape of a logarithm looks like. And ln is just a special logarithm. The domain of this. What am I not allowed to take the log of? 0 or negative.
Or a negative.
And look at this graph. It never touches 0 or is negative. So my domain is everything bigger than 0, right?
So
All
I
whole
will
numbers.
use 0 to infinity.
Or you could say x is greater than 0, not including 0. Not equal to. When we talked about exponential functions, we always talked about this y-intercept, because if you took anything to the 0 power, you always got 1. Well, now if you take the log of 1, you're going to always get 0. So we always talk about the x-intercept here. And again, disregarding any transformations that could move this graph, if there's nothing added or subtracted to move it around, the intercept is going to be at 1. Because that's when you get, that's your exponent of 0, right?
So we look at the y0 and then the x value is our x.
Yes. And the vertical asymptote, just like e to the x, or any number to the x power, if there's no transformations on exponential, our horizontal asymptote was the x-axis. Well, now our vertical asymptote should always be the y-axis, which would be the line x equals 0. If this graph was moved up or down, not going to change it, but if it's moved left or right, it's going to change my asymptote. And so we'll look at a couple of those in a minute, of graphing those. Graphing not a huge part of your test, but definitely a couple questions on your test over graphing. And we'll review this again before we have a test. But the idea is just making sure you're comfortable with the shape and the asymptotes, I think, and then it's not so bad to do. Questions about that before we do another one? I like the other bases when I can pick numbers that work out nicely, but like I said, your book picks a lot of these, so
How many more are there?
I don't know.
Never makes a full size. You can't stop next time.
No, I don't want you to don't do that because Mr. McClure did that and I saw like 20 slides and we were at number 2. It was very perfect. Yeah, I did that.
Maybe 2 more? I don't know. Who knows?
Shots fired. She hates us. Student population.
I like to think about transformations when I do a problem like this to help me know what the graph's going to look like. Like a negative out in front, what does that do to my graph?
Reflects on the x. No.
It does reflect. I think it reflects in the x-axis, right? Think about negative x squared. It flips it down. So a negative out front means that we're now going to reflect this over. We should be getting negative numbers. We're going to get positive numbers. And what does a number inside my function do to that graph? It moves it left or right, and a minus actually means it moves it right 3. So that helps me know that my graph looks correct when I do this. A number out here is going to move it up or down. Okay? So just like exponential functions, my advice is pick what makes the exponent go to 0. My same advice is on here, except for if you pick what makes this go to 0, can you do that?
No.
Because if you plug 3 in there, that is undefined, right? You can't take the log of 0, which tells me that my asymptote has moved to the line x equals 3. It's shifted over. So don't make your graph go past that. I'm going to go ahead and say that means my domain is going to be from 3 to infinity. I can only pick values bigger than 3.
So if it's not an apprentice-y thing, it doesn't change the asymptote.
It doesn't, because it just moves it up or down.
Then the asymptote will be the first letter of your domain.
Always.
It's
Well, it could be switched because there could be another negative somewhere, and if it was flipped over the y-axis, it might change that from negative infinity up to 3, just throwing that out there, but yes, that will always be in your domain somewhere. This is log base 10, which means technically you could use your calculator, and as long as you pick a number bigger than 3, then you're going to get the right shape. I want to pick some special numbers first, and then I'll let you pick some decimals. But Grady says we should pick 4 for x,
You get negative 0.
because you would get negative log of 4 minus 3 is 1. And log anything of 1, since the what power equals 1 is 0, you don't get negative 0, you just get 0. And think about, normally I told you that x-intercept is at 1, so if we just shift 3 units, it makes sense that it's at 4. We could also pick a power of 10, but I can't just pick 10 here, right? I have to pick a number, and when I subtract 3 would equal 10. So what number can I pick there? 13. Because I would get negative log 10 of 13 minus 3 is 10. And what is log 10 of 10?
Negative 1.
1, but the negative in front makes it negative 1. I don't care if you actually pick big numbers or you pick numbers that work out to be decimals. Like we could pick 5, we could throw 5 in here, or 7 in here, or whatever. But if it wasn't base 10, or it wasn't ln, you have to be able to pick numbers that work out nicely to give you powers. And so that's why I like to show you that. But let's just pick like 8 here just to show what you would get. And you can just type that directly in your calculator. You can just hit negative log, because that's base 10. And then you could just say 8 minus 3 is 5, or you could actually just write 8 minus 3 and do no brain work at all. And I got negative 0.7. That should be enough to make the shape if you know what the general shape looks like. 5, 6, 7, 8, 9, 10, 11, 12, 13. Negative 1. Dang it. I forgot to put this one down. I do.
So yeah, there's this guy got, what's that? 1. And there's this guy who's
Isn't it weird that my smartboard doesn't have?
much better.
And 4, 5, 6, 7, 8. Negative 0.7. We're going to say that's about right here. It helps me sometimes to draw my asymptote in, because that way I know not to pass 3. You don't have to do this, but it kind of just gives you some guidance to make sure you don't make your graph go way over here. Because it's reflected over, instead of coming down like this and going up, it's going to flip up, and now this side's going to go up, and this side's going to slowly go down. Like, think about it's not going to get to negative 2 until 103, because that's would give you the power of 200. So it's going to go down very, very slowly. That's exciting stuff, right? I think the last slide here is just comparing like domains and intercepts, just to kind of give you some guidance, and then you can use your transformations from there. Are you okay with that? Good, we're gonna get. I think logs is never really a fun day. It should really be like spaced out, but. some guidance over the basic graphs of log a of x and ln of x. Transformations change this. So this is only true for these functions. And then if there's a negative thrown in there, that's going to reflect it. If it's a number added or subtracted inside, it's going to move it left or right. A number added or subtracted outside is going to move it up or down. But if you know this, and you know transformation rules, it makes graphing a little bit easier. And remember that ln is just a special log, so all of this is true for this also. So the domain of a logarithmic function will never be all real numbers, because you cannot take the log of 0 or a negative number. So unless there's a horizontal transformation, the domain will always be from 0 to infinity, not including 0. And the range, if you think about those graphs we just graphed, it kind of looks like this. Although this goes up really slowly, it does eventually go up forever. This side goes down forever, so the range is all real numbers. And if you go back and you look at our domain and range for exponential functions, they just have switched, because that's the definition of an inverse. The domain and the range have switched places. That's why this graph has a vertical asymptote. Exponential graphs have a horizontal asymptote. I know, next one's homework, honey. No, I wasn't counting homework. But if you want to quit, I'm okay with it. I'll sign a paper right now. The x-intercept is going to be what answer gives you a power, or what gives you a power of 0, right? When the exponent's 0, the answer is 1, so that's why that's your x-intercept. Unless it's reflected or flipped around, this should be an increasing function. It's continuous. And your vertical asymptote will always be 0 unless it's reflected and translated left or right, right? If it's shifted left or right, then your asymptote moves. And just like exponential functions, I'm really grading that asymptote when I'm grading your graphs. Because if you don't have the asymptote in the right spot, that's a big deal for me, because it means you don't understand where the asymptote is supposed to be. Okay? I'm sure any notes down today, Grady. Ridiculous. Why didn't you write down his phone? He's too cool.
Actually, you don't even know the phone.
37 through 40 is matching the equation with the function. Use the reflections and the asymptotes to help you match those up. But then 43, 45, and 49, those are all graphing, and they're, it says sketch by hand and support with the grapher. Well, I'm okay that you just sketch by hand, and they're all odd, which means you could support your answer with the back of the book. But pick points, make sure your asymptote's labeled right. I expect graphs on those. And then there's just some applications. I'm sure we'll talk about some of these tomorrow. But 59 and 60, I will tell you for 59, it tells you to go back and look at a table in your book. And every year I tell people this for the homework, and the next day they say, I don't know where I'm supposed to find this information. But it says table 3.17, and you just have to flip back one page to find that table to answer those questions. And then 60, it gives you an equation, and 72, it's just a little thinking question also. So I'm going to pass back the worksheets from yesterday that you turned in, because I really want to talk about them, but go ahead and get started on this, and then I'll